In the world of software development, understanding system architecture is crucial for building robust and scalable applications. Think of architecture as the blueprint for your software. It dictates how different components interact, handle data, and scale to meet demands. Choosing the right architecture is a fundamental decision that impacts an application's development, deployment, and long-term success. Two prominent architectural styles that dominate modern software development are monolithic architecture and microservices architecture. Each approach comes with its own set of advantages and disadvantages, catering to different project needs and scales. This essay will delve into the intricacies of both monolithic and microservices architectures, comparing their strengths and weaknesses to help you make informed decisions when designing your software systems. Monolithic architecture is a traditional approach where an entire application is built as a single, unified unit. Imagine a large container holding all the software components tightly coupled and interdependent. Core functionalities like user interface, business logic, and data access are interwoven and run as a single process. This can lead to challenges as the application grows in size and complexity. One advantage is its simplicity, especially for small applications. Development, testing, and deployment are straightforward since everything is in one place. In contrast to the monolithic approach, microservices architecture advocates for building applications as a collection of small independent services. Each service represents a specific business capability and runs as an autonomous process, communicating with other services through lightweight mechanisms like APIs. Think of it as building a city with independent buildings, each serving a specific purpose. This modularity offers several advantages. Firstly, microservices promote flexibility and agility. Teams can develop, deploy, and scale services independently, allowing for faster development cycles and quicker responses to changing business requirements. Secondly, microservices enhance fault isolation. If one service encounters an issue, it doesn't necessarily bring down the entire application, as other services can continue operating independently. This isolation improves the overall resilience and availability of the system. Section 4. Deployment and management: monolith versus microservices. Deploying a monolithic application typically involves deploying the entire codebase as a single unit. This process can be straightforward for small applications but becomes increasingly complex as the application grows. Any small change requires redeploying the entire monolith, which can be time-consuming and resource-intensive. Microservices, on the other hand, are deployed independently. This allows for more granular control over deployments and enables continuous delivery and deployment practices. However, managing a large number of services introduces its own set of challenges. Orchestration tools like Kubernetes have become essential for managing the deployment, scaling, and networking of microservices-based applications. These tools automate many of the complexities, but they also require a learning curve and additional operational overhead. Section 5. Understanding, debugging, and maintenance. Understanding a monolithic application can be easier initially, especially for new developers. Since everything is in one place, tracing code execution and data flow is relatively straightforward. However, as the codebase grows, it can become challenging to maintain a clear understanding of all the dependencies and interactions. Microservices, with their modular design, promote better code organization and understanding. Each service has a well-defined purpose and interacts with other services through clearly defined APIs. This modularity makes it easier for developers to focus on specific areas without needing to grasp the entire application. Debugging can be more challenging in a microservices environment. Since services are distributed, tracing an issue across multiple services requires tools and techniques for distributed tracing. However, the fault isolation provided by microservices can make it easier to pinpoint and resolve issues once they are identified. Section 6. Performance, scalability, and choosing the right architecture. Monolithic applications perform well for small to medium-sized applications with moderate traffic, but as traffic increases, they can encounter performance bottlenecks. Scaling typically involves vertical scaling, adding more resources to the same server. Microservices are designed for scalability. Each service can be scaled independently, improving performance under heavy load. This horizontal scalability is a key advantage, handling massive traffic and adapting to demands. Choosing the right architecture depends on application size, traffic, team expertise, and complexity tolerance.